All right, in this yellow box is the definition of a reference angle. The definition is we want to let theta be a non-acute angle. So non-acute would be something greater than 90 degrees, falling in standard position that lies in a quadrant. The reference angle is a positive acute angle theta prime. So our reference angle has to be less than 90 degrees. And it's formed by the terminal side and the x-axis. So here are some examples. So here would be our angle theta, which is greater than 90 degrees. How we create our reference angle is we have our x-axis, and then we're going to go up to our terminal side. So this distance here is our reference angle in the blue. Second one, here's our standard position, our terminal side, and this is our angle theta. How we create that reference angle, start on your x-axis, go to where your terminal side stops, and this would be your reference angle in the blue. Last one, initial side and terminal side, and this is our angle theta in the green. Our reference angle starts on the x-axis and goes to the terminal side. So that what's in the blue is your reference angle. So how you find them is you can subtract theta from 180 degrees, subtract theta from 180 degrees, or 360 degrees. So you can find the measure of this angle, and that angle there. So let's go ahead and practice it. So 345 degrees is our angle. So I'm going to graph it out. So this would be 180, 270, so pretty close to a full revolution around of 345 degrees. Now we want to find the reference angle. So we start on the x-axis, and we're going to go back to that terminal side. So this is our reference angle in the green. So how you find the reference angle, since it's falling in quadrant 4, we're going to use this equation right here I'm highlighting in the yellow. So we want to take this full revolution of 360 degrees So the full revolution would be 360 degrees, and then we're going to subtract out 345 degrees, the blue. And what we're left with is 15 degrees. So that's how large this small angle would be 15 degrees. Second example, the angle is 5 pi over 6. So we start with our standard position. This small angle here would be pi over 6, another pi over 6, another pi over 6. So right now we're at 3 pi over 6. Count 2 more. And we would be right there at 5 pi over 6. So this angle starts at 0 radians and finishes at 5 pi over 6. And we want to find out, starting on the x-axis, working our way back up to that terminal side, how large is this angle right here? So on this slide, we are in quadrant 2. And we want to find out in radian measure what that would be. So think about from here over, that is a distance of pi. And we want to subtract out this blue angle right here so that we're left with what's in the green. So we're going to go ahead and change that pi to a like denominator. So I'm going to change that to 6 pi over 6. And I'm going to subtract 5 pi over 6. So 6 pi over 6 minus 5 pi over 6 is pi over 6. So this small angle right here, our reference angle, is pi over 6. Here's another one. So we're going to graph negative 135 degrees. So we're going to go in a clockwise direction and graph our angle theta. And now we want to find our reference angle. So we start on the x-axis, work our way down to that terminal side. And this will be our reference angle. So we want to find out what is the distance that that small angle measures. So this angle all the way there is 180 degrees in the orange. And we're going to subtract out what we have in the green, 135 degrees. And then what we'll be left with is our blue angle. So that blue angle is our reference angle. So that would be 45 degrees. The next one, 2.5 radians. So what is 2.5 radians on the unit circle? So theta equaling, let's say, pi. Pi is 3.14 radians. Pi over 2 would be approximately 1.57 radians. So this is somewhere between pi and pi over 2. So here's pi over 2, and this is pi. Our angle falls somewhere in this quadrant 2. So there's our angle theta. Our reference angle will be that x-axis back up to our terminal side, and noting that as theta prime. So how we find that reference angle is the distance halfway around that unit circle is a distance of pi. So pi, and now we're going to subtract this blue angle right here, 2.5 radians. Well, this will need to enter into our calculator. So go ahead and type in pi minus 2.5 radians. So this angle would be about 0.642 radians. So when you try to find reference angles that are greater than 360 degrees or 2 pi or less than 360 degrees or 2 pi, we need to work with coterminal angles. So if we have something greater than 360 degrees or 2 pi or less than negative 360 pi, we have to do our reference angles by finding the coterminal angles. So here are the steps. You want to first find a positive angle that is less than or equal to 360 degrees or 2 pi. Then draw that angle alpha in standard position, and then you find your reference angle like we've done on the previous examples. So here is our angle 580 degrees. It is larger than 360. So we want to find a coterminal angle that is between 360 degrees or 2 pi. So we're going to subtract 1 revolution. So alpha and theta are coterminal. So we're going to go ahead and graph that angle, alpha. So start at 0 and go to 220 degrees. So this is our angle alpha. Now we finish the problem by finding the distance back up, and that'll be our reference angle. So to find our reference angle, we're going to take that 220 degrees, which is the distance from here to there, and then we're going to subtract 180 degrees. Giving us 40 degrees. So this angle right here is 40 degrees. Example C, negative 13 pi over 6. We need to find alpha. So we right now have a negative angle. So we want to add a revolution in the positive direction so we can start to get an angle between 0 and 2 pi. So we're going to add the equivalent of 2 pi, which is 12 pi over 6. So those denominators are alike. And we get negative pi over 6. So it wants us to find an angle between 360 and 2 pi. So then we're going to add another revolution of pi over 6, giving us 11 pi over 6. So that's the angle we're going to work with that is coterminal. There is alpha, which is 11 pi over 6. Now we're ready to go ahead and find our reference angle. So we want to find out what is that distance right there in the purple. So how we do that, the full revolution is 2 pi, and we want to subtract out the green. So we're going to take 2 pi, the full revolution, and subtract out the green to see what we're left with. So we're going to change that 2 pi to 12 pi over 6. And that angle is pi over 6. So that's the distance right there.